Hi, everyone. Thank you for joining our session today with Microsoft, Azure, and HashiCorp, protecting your data in a zero trust world. I hope everyone is staying safe and healthy out there. My name is Mina, and I'm part of the partner marketing team here at HashiCorp. A few housekeeping items. This webinar will be recorded and available after the event. If you have any questions throughout the presentation, please put them in the Zoom chat, and we will have a Q&A session at the end. So with that, let's go ahead and get started. I'd like to introduce David Branscombe, who is the Global Enablement Lead for Security and Identity at Microsoft. David, I'll let you take it away.
Hi, everybody. Good to see everybody here, and looking forward to working with HashiCorp. And hopefully this webinar will be a little bit entertaining and very educational for you.
Hey everyone, my name is Iman Ranthawa. I am co-presenting with David today. Super excited to have David's expertise and his vision of security and what the Microsoft platform brings to the problems that you're running into. Super excited to have David co-present with us. I'm a partner solutions engineer here, and I'm lucky enough to work with smart people like David and see how our solutions help solve some of the challenges your organizations may be running into. I'm going to turn off the video here so that we have a smooth experience with the presentation, and I'll let David kick it off.
So let me ask you a question. What do you remember about the year 1998? Maybe some of you weren't even born at the time. You remember this guy? It doesn't look like Hillary Clinton next to him. How about these? Did you have a set of these? Sony Walkman? Maybe you remember Michael Jordan's flu-ridden finals game. And did you know that Google got started in 1998? Here's something that I remember from 1998. At the time, I was working in a financial institution that was running Novell. And Novell, GroupWise, NDS, that was really the dominant operating system, network operating system. But there was this up-and-comer called Windows NT, and that was quite a battle. I remember that certainly. At the time that I was running Novell, I had an absolutely unguessable password. Trust no one. Now, it's interesting that on July 16th, 1998, CERT reported an incident where an attacker had found 186,000 encrypted passwords. And at the time that the attack was discovered, 47,000 of those passwords had already been cracked. I shudder to think about how quickly those passwords would be cracked today, but back in 1998, that was a big deal. And sometimes I wonder if my absolutely unguessable password was in that stash. Let's fast forward just about 15 years to the year 2013. So at that point, I was working at Microsoft. Hopefully my security skills had gotten quite a bit better. But I was rummaging around on a place called Pastebin, and many of you are probably familiar with that. And I came across this password list. And as you can see, my absolutely unguessable password was listed in the top 10 passwords in Pastebin. So that was a little bit of an eye-opener. Probably some of you have seen what we call word clouds, where they will describe different words, and you know, the larger the word or the higher it is in a certain area, the more common that word shows up. And so this was a password word cloud. And as you can see, there's my absolutely unguessable password, trust no one. It was even more commonly used than something like ABC123 or people's names. So my password didn't stand the test of time. Now, if we fast forward a little bit further to today, Things have changed quite a bit in the last. Different researchers in the Microsoft Digital Defense Report from last year identified that the password admin was used more than 20 million times on different IoT devices over a 45-day period where those passwords were evaluated. Add to that the fact that the financial services industry saw a 1,318% increase in ransomware attacks in just the first half of 2021. And finally, it was predicted back in 2016 that by 2022, which is where we are, a third of successful attacks experienced by enterprises would be due to the existence of shadow IT resources. And when we talk about shadow IT resources, we're talking about services or applications that are being used within an organization but haven't been approved by the IT department or aren't managed by that IT department. So we see a lot of problems that the security industry is facing and that individual organizations are facing. We recognize that cyberspace is in fact the new battlefield. We're seeing attacks on government organizations, on corporations, and even on civilians from different nation state actors. Attacks are no longer just against governments or enterprises directly. We're seeing attacks against private property, the mobile devices that we carry around every day, the laptops that are on our desks, even public infrastructure. Just a year or two ago, there was an attack on the water system in Florida in one of the counties, attempting to ransomware attack that infrastructure. So what started a decade and a half ago as a sense that there were, maybe some teenagers in a basement hacking their way through corporate infrastructures, it's moved far beyond that. It is a very sophisticated international organized crime organization or groups of organizations. And in even worse situations, we have very well-funded, very sophisticated nation-state attacks. If you compound the problem with the fact that security skills are in short supply, there was an annual survey of 620 IT professionals across North America and Western Europe that was done, and 51% of the respondents made the statement that their organization had a problem of a shortage of cybersecurity skills, which is up from 23% in 2014. So the security landscape is not only getting more complicated and the stakes are getting higher, but you add to that the fact that many enterprises simply don't have the resources, the people that they need to meet their security requirements. And then the third topic is virtually anything can be attacked. Anything can be corrupted. The number of connected devices or devices that are connected to the internet in 2018 was more than 11 billion. That's billion with a B. And that doesn't include computers and phones. We're talking about IoT devices, your refrigerator, your thermostat, your door locks, your Ring doorbell system. We can connect virtually anything and everything to the internet, which means all those things can be used as a tool for an attacker, and the operation of those things can be disrupted. So everything from the cloud to the edge needs to be considered and it needs to be protected. Now that brings us back to my original password. Right? Protecting your data requires you to protect your identities. In other words, you can't trust anyone. You have to trust no one. And that's really the principle behind Microsoft's zero trust strategy. So how does zero trust employ these new principles that we have to take into account? Well, essentially what happens is every access request that's made by a person or a device has to be strongly authenticated. It has to be authorized within certain policy constraints. And we have to look at the actions, the behaviors before granting access to this user. So we're looking for anomalies, unusual behavior. Are they logging in at a time that's unusual? Are they logging in from a location that's unusual? These are all things that have to be taken into account before access is granted. So everything from the user's identity to where the application is hosted is used to verify the request and prevent unauthorized access to data. And in order to limit the impact of these potential breaches, we apply what we call segmentation policies to the network. And so we employ the principle of least privileged access. We use analytics to help detect and respond quickly. And by doing this, we can ensure or take significant steps toward ensuring that the network is protected. The essence of zero trust is simple. It's making the statement that security models that assume that access is safe based simply on network location. In other words, if you're inside the network, the assumption is that you're safe. That assumption is no longer adequate. It doesn't work anymore. So when we talk about zero trust, this is um, the representation that maybe you most often see in terms of the way that Microsoft portrays zero trust. So on the far left side, we have our identities, our users, our managed identities, our services. We have our endpoints, and they need to get to either data or apps, pieces of our infrastructure. They need to connect to different parts of our network, which you see on the right-hand side. And in order to do that, they have to go through this engine, this security enforcement policy that we see in the middle. And that security enforcement policy is going to apply controls. It's going to look at the context of how the user is connecting to these things. And it's going to use the principles that we see just above it. We're going to verify the user explicitly. We're going to grant them the least amount of access necessary to do what they need to do. And we're also going to operate on the assume breach methodology or assumption. Now, the reason we do that is because we want to reduce what we call the blast radius that an attacker might have. What a blast radius is if an attacker is able to get into your network, where can they go from the place where they land? So let's say that they compromise somebody's laptop machine. Where can they go from there? Can they get to a server? Can they get to a service? Can they get to somebody else's laptop? And so what we're trying to do here is reduce that blast radius, reducing the areas that the attacker can expand their footprint in your environment. And the way we do that is with things like network segmentation, preventing them from having free reign across the network by reducing the number of network segments that they can get to. So again, if we look down at the bottom, we're using this principle, trust no one, never trust, always verify. And what does this lead to? So zero trust starts with securing the people and the devices they use to get their work done. The reason we require so much authentication and verification of identities is that the use of passwords has led to a number of problems. We've seen research done by Verizon, and they made the statement that 80% of the breaches that they've seen involve the use of lost or stolen passwords. And 60% of bring your own devices are not secured by the IT department. So your mobile phone that you bring to work, maybe you have a tablet that you bring to work. So if users are going to be allowed to use their own devices, then we have to make sure that the process that they go through to connect to corporate resources is explicitly verified using strong authentication where possible, maybe using MFA, maybe using a different a token or something like that to authenticate, and that we're verifying that they have the least amount of access to those resources that they absolutely need. So if we look at the zero trust architecture, again, at a little bit different angle, we still have our identities and endpoints on the left-hand side. We still have our data, apps, and infrastructure on the right. But what we're going to focus on in the middle here is the policies. So we implement policies that ensure that we're verifying that the humans or non-human identities on the left-hand side have gone through this process, that they've had this policy applied to them that ensures that they are authorized to access the segment of the network, which you see in yellow. And then from that network, they're able to access different pieces of the infrastructure. Same thing with endpoints. And with endpoints, we're talking about your mobile devices, the corporate managed laptops or desktops. We want to make sure that they are compliant with the policies that allow them to access these resources. So in other words, you can say, if this iPad that the person has brought to work, their own personal iPad, if it isn't up to the latest iOS version and it doesn't have some form of encryption on the device, then we're not going to allow it to access the SharePoint infrastructure. Maybe they'll be allowed to access the corporate intranet and view data and documentation, but they won't be able to get to or download sensitive data from the SharePoint location. So again, when we look at the middle section, policy optimization, zero trust policy, and threat protection, these are the principles that are going to ensure that the entities on the left-hand side are fully vetted before they can get to the resources or pieces of our infrastructure that exist on the right-hand side. Now, if we expand into one of the areas in a little bit more detail and look at identity security, one of the things that each organization has to ask themselves is, how strong is my identity and my access security? So am I making access protection stronger? And at the same time, is it possible for me to be making things easier for my end users? So this is about how people sign in, how often they have to sign in, and how we authenticate that they are who they say they are. And we find that across all of our analytics, as we look at something like 450 billion authentications that we process every month with Azure Active Directory and different Microsoft properties, the proper application of a username and password is not a tremendous predictor of a genuinely authenticated person. In other words, just because you have a username and password is not much of a guarantee that you are who you say you are. So how can we improve that? How can we get to a world that is beyond passwords, beyond what we know are faulty technologies for proving authentication, and at the same time make it easier for end users? The second question that's listed here is, how much control do you really have over access? Not only who is accessing what, but also, can those access control policies change depending on changing conditions? So for example, I consider myself to be a pretty trustworthy employee of Microsoft today, and I might be allowed to access certain sensitive information that the company has available. Now, tomorrow, maybe I get a bad review or something like that. I might be a slightly less trustworthy employee. And again, that could be for a variety of reasons. But now I might not be allowed to access that same information. So can your access control policies adapt to those changing conditions? Can you make decisions on the fly? This is one of the techniques that many industry experts and analysts are championing that coincides very, very closely with Microsoft's zero trust methodology. Some analysts refer to this as adaptive security. And so the identity space is the primary control point for that type of capability. And then the last thing we ask here at the bottom is, how do you protect user credentials? And this is really about the idea that in the imperfect world that we live in, where we do sometimes have to rely on username and password, how do we keep those credentials protected once they're used? Right? So that when they're stored as part of an operating system session, for example, they can't just be hijacked by an attacker and then used to access other things that a genuine, legitimate user is not trying to access. So these are some questions that many organizations are struggling with. So our approach, Microsoft's approach in identity and access management, is really threefold. First of all, secure authentication. Um, and again, if you've heard Microsoft speak at all, you realize that our belief is that passwordless authentication is the future. The second is conditional access. So conditional access to get to the point where we can achieve zero trust. And lastly, identity protection, safeguarding those identities when they're used as part of an operating system's session or an application session. Some of the technologies that we make available for this type of security are Windows Hello, Microsoft Authenticator, and FIDO security keys. Just a couple weeks ago, Microsoft, Apple, and Google made the announcement that FIDO was going to be a supported platform so that users could authenticate using their phone, using the FIDO protocols. They could use their phone to authenticate to their laptop, which is a huge step forward in authentication. So these are some of the areas where we see the security of authentication going. But obviously, HashiCorp has many other um, tools and resources that can help facilitate that journey to zero trust and secure authentication. So I'm going to turn it over, and we'll be able to hear it from HashiCorp's perspective.
Yep, thank you, David. We've certainly come a long way from the days of Novell. So here at HashiCorp, we build tools that let organizations operate applications effectively in the modern cloud infrastructure world, right? And many of our projects have been downloaded millions of times, and they're de facto industry standards. The root for all this, pretty early on in HashiCorp's history, our co-founders recognized the importance of technology and platform agnostic workflows. So what you see is technology evolves relatively rapidly compared to how fast organizations adopt new processes. So, there's already, Kubernetes, the latest version's out. We're still trying to figure out how to update to the release that came out 3 quarters ago. How do we start adopting these new policies and the new ways of working that will be necessary with the latest technologies, right? That's a challenge all organizations are running into. What our core founders recognize is the only way to keep pace with changes is to have consistent and standardized workflows that will continue to work regardless of the underlying technology. And this is the philosophy that permeates all of our tools. This is what you see organizations doing with their tools, is building these standardized workflows and operating models for cloud adoption. So today we're focused on security here today, and I'll touch on Vault and Boundary and some of the problems that they're solving. So with the emphasis on identity from Microsoft is wholly justified. That's what we're doing with Vault as well. Vault is designed to decouple the identity of users and applications from the system they're trying to access. So the goal with this is, if you take a zero trust approach and you adopt identity-based security as the way your applications are going to be allowed access, your applications need to identify themselves before they'll get access to your data. And what you see is that certain types of identities make sense for certain applications. So for example, a cloud native application that you develop specifically for Azure might use managed identities tied to application instances. But the applications that you have on-prem might still be using service accounts that they get from LDAP. So what we see is most organizations are kind of standardizing towards a hybrid cloud approach. So you end up with multiple ways of managing identities and multiple IAM methodologies that need to be applied. And that gets hairy pretty quickly. With Vault, as is a philosophy for our company, you build a standardized workflow that lets your applications use the preferred identity mechanism and then gain access to any system of your choice after the application authenticates itself. And so far, as we were talking through this, right, we've only touched the technology part of managing identities where there's different ways that applications may authenticate themselves. But the process part around this technology and the people part around these technologies is even crazier. So the typical way an application gets access to privileged information or your data is it provides a credential and your backend system validates that credential and we give you access to data. This is pretty much how every single application out there is working. So to get this credential in place, usually a developer and ops team member has to put this credential, so it's accessible to the application. And the process for doing this is where the kind of second big challenge comes in. So we have various ways the application can authenticate itself, but we also need to provide a credential so it can authenticate. The process for this is usually ticket-based, cumbersome, and extended. There are multiple actors involved, and the request has to be understood and translated and kind of sent to multiple different teams. And throughout this process, there's a couple of challenges here. The first one is you have to manually go through this process, right? This is anytime there's a credential update or you need new credentials, this is this extended weeks-long process that could end up taking place. The second kind of challenge, besides the time it takes to get new credentials, is usually these credentials are placed in configuration files so they're available to the application. And those configuration files have a bad habit of ending up on GitHub and being exposed to the public. So there's those two kind of challenges. The other part of this is developers are generally friendly people and they want to help their teammates meet sprint commitments. So what you often see happening is instead of waiting weeks for these new credentials get shared and get reused pretty often, right? So this creates this problem of credential sprawl. So we have a couple of challenges. This manual process that takes a while. We have credentials potentially traveling in clear text from the security team that created the service account all the way to the initial developer, potentially sitting in clear text and configuration files. And then there's a lot of credential reuse, which kind of eliminates the ability to determine where a specific credential has been used. So we fix all of this with Vault. What Vault does is it sits in the middle of this entire process. So instead of your credential, your application presenting the credential to the backend system, it presents the credential to Vault, and Vault takes the responsibility of communicating with the backend system to confirm the identity. The nice thing is every Vault action is takes place through a standardized API. So you can use this API to build workflows for users, for machines. Generally, we see Vault being used with applications and machines, but you have the extension point of a published REST API that you can use to build whatever custom workflow makes sense for you. So the application presents its credential to Vault. Vault validates it with the authentication backend that you've configured. And then Vault translates that access into access to other systems. Vault translates that identity into access to other systems based on policies that generally security teams configure. So the idea is that security team is the central choke point. They still have the control to be able to determine who has access to what. They can configure these policies that will allow any application that authenticates to Vault to be able to translate that identity into access to another system. The third leg of the stool here is the secrets, or the secrets management piece that you see here. Vault has native integrations with many systems that applications want to get access to, and Vault can generate short-lived credentials on demand. So what that means is when an application logs in, Vault generates an instance-specific, that login-specific credential. And we generated this temporary credential. We know it's not being used anywhere else. And we know where we can revoke it. And when we revoke it, the only application that will lose access is that specific login. So the blast radius, again, is severely contained, and you're able to determine exactly who had access to what system based on when this credential was generated and who generated it and how long it was alive for. And Vault obviously records every API interaction in the background. So you have a definitive audit log of who had access to which system and for how long. Now, excuse me, the way this looks like in action is, you have a standard application, you need access to a database. You have the very secure password or trust no one here. This is the traditional workflow where you supply your application a credential, it accesses a backend system and gets access to data. What this changes into, the application actually communicates to Vault. Vault in the background talks to the system that you're trying to get access to and creates a temporary access mechanism. For database, it's generally users. For something like Azure, it might be service principals. This is done by Vault in the background, and then Vault returns this credential back to the service instance that logged in and requested access. Then your service is able to just use that credential and get access to the backend system that it was initially trying to access there. So because this is a fully automatable process, it's all happening over REST APIs. And these credentials are generated specifically for that instance. We have full control over the lifecycle of this credential. So a common example, common workflow is on every deployment, we revoke the previous credential and we get a fresh new one. This drastically reduces the chance of accidental exposure and the risk from it, right? If you had a credential that's only valid for, let's say, a couple of days, even if it's logged in your log ingestion pipeline and later on someone gets access to it, if it's after the week the credential is valid for, your adversary can't use that credential to do anything. We revoke that credential automatically after the week that was supposed to be valid for has passed. So this process, the kind of thing that I walk you through here is pretty seamless, works well for applications where you can script specific interactions, right? It's pretty easy to update an application that before you start up, you make a request to Vault and you get a temporary credential, and that's what you use to access the database. This is really hard to do for humans, right? Humans represent the other half of clients that will need to communicate to these secured systems where data is stored. And humans are pretty terrible at speaking REST APIs. The solution for that is this common kind of approach that we take where we use network segments to protect access, right? We protect our application by placing it in an isolated network segment where you use either a VPN or a bastion host to get access to it. And the goal of this approach is to isolate access to specific well-known IPs that might be your VPN concentrator or the bastion hosts that you've configured. You put a firewall that will allow access from only those specific IP addresses. And then you're on the host after connecting to your bastion, you get to the host where your application is running, and then you're able to log in and debug things and so on. There's a huge challenge with this, especially in today's world where many people are not in the office and you have this VPN approach that is a requirement to connect to these secure networks where your applications may be running. The first one is this is a kind of, again, a manual onboarding process where you create a request for someone to be onboarded to the VPN. There are credentials that need to be shared, whether it's SSH keys or API keys and so on. There's a manual process that needs to happen. After this, after you're connected to the VPN, you again have kind of wide open network access because usually VPNs and bastion hosts provide coarse-grained access. So there's a potential for abuse here where you could have some horizontal movement because, like I said, usually you have the purpose of the bastion is to get access based on IPs, but once you're on the bastion, you have access to a lot of hosts which can give you horizontal access. The other problem is IP-based firewalls, especially in a cloud type of landscape where dynamic IPs are the norm. It's hard to have firewall rules that are not either too open or are not too restrictive where they frequently need updates, which are done manually again, to be useful. And then after all this, let's say you've solved all these challenges, you land, you have network access to where your application is running. To be able to do anything meaningful, you still need sort of elevated credentials, which you log in with, whether it's a database admin or someone debugging an application running on a host, you still need to log in. And then again, you're using these elevated privileges, elevated credentials, which, as we talked about earlier, may have traveled through that chain of manual ticket-based processes. So lots of challenges here. Again, wouldn't it be great if there's a way for humans to authenticate and easily get access to other systems? And that's exactly what HashiCorp Boundary does. Very similar to Vault, it allows you to use your identity of choice, log into Boundary, and based on the roles that are mapped to your identity, you get granted access to various different systems in the background. The nice thing about Boundary is it takes care of that VPN connection proxying for you. And when it connects to the target system, it automatically takes care of providing the right credentials to give you access to the target system as well. So the great thing you can do with this is integrate Boundary with Vault. When you log in, you get session-specific credentials. So there's a database that you're trying to get access to. Currently, only your application has access. You log into Vault, you log into Boundary. Boundary validates that your identity using Microsoft's platform and multi-factor authentication, or applying all the threat protection rule that Microsoft's platform provides. We get a valid login. Boundary talks to Vault to request credentials for that database. Those credentials are created specifically for your session. And using those credentials, we proxy your connection and connect you to that database. Once you're done with that session, Boundary automatically requests the rotation of those credentials, and those credentials are gone. So that specific set of credentials that allowed you to get elevated access into this database existed just for the duration of your session. There's no potential of that credential being leaked. And even if it's leaked, as soon as you're done with your work, that credential is gone. Maybe it was accidentally logged, or it was printed while you were doing a screen share. If someone tries to use it, it will not work because we've rotated it in the background. So again, the core idea with this is to give you a centralized workflow that will let you log in with identities that you already know and use to get access to systems that you need to get into, while keeping the connection itself and the credentials used for your connection secure. So great way to kind of, with the modern workforce where people are working from home, there's no direct connectivity to resources, to avoid that manual VPN connection creation and onboarding process. Boundary lets you map user identities that you're already using to roles, which can be mapped to groups within your identity platform, and those give you access to target resources. This sort of brings us to this kind of new way of working and getting access to these resources. You log in with your trusted identity. So an administrator configures Boundary to work with Azure AD once. From then on, everyone is able to use their Azure AD credentials and log in. Then based on the groups you're part of in Azure AD, we map you to a specific role. Using this role is a little bit more stable than using IP addresses, right? And before this, in the old approach, the IP address is the way of getting access. Well, now we can use group memberships within our identity platform, which are a lot more stable, and we can update group memberships. Anytime you log into Boundary, we'll receive your updated group memberships and give you access. And then we give you access to a specific host that you're allowed to connect to. This prevents kind of that horizontal movement we were talking about. If you've been assigned the role that gives you access as a DBA to database instances, you cannot go and log into application instances, or you can't connect to prod database instances because you are a junior DB and we only gave you dev access. So even though we are proxying your connection, we're connecting to specific hosts. So we've eliminated the risk of horizontal movement. And then finally, when Boundary connects you to a target application, it takes care of providing the credentials that were generated for you or that were stored for you. It takes care of supplying those credentials and creating that connection for you. So once again, there's no need for you to manually copy paste credentials or share credentials with your teammates. Whenever you log in, you get session specific credentials, and that's what gives you access to your target systems. This sort of encapsulates the multi-cloud zero trust approach that you can get to with HashiCorp's tools, building on Microsoft's identity platform. So our tools let you take Microsoft's identity platform to places beyond Azure and beyond where places where Azure and Microsoft infrastructure is running. You get the ability to enforce identity-driven controls for data access for both humans and machines, as you see here, regardless of where your applications are running. So users, human users, log into Boundary and use the variety of multi-factors authentication solutions offered by Microsoft and get access to applications based on the roles assigned to them. Applications use Vault, and whether they're using machine identities or LDAP service accounts or whatever identity of choice, and they authenticate themselves to Vault and get access brokered by Vault into other applications and machines. The power of all this combining HashiCorp's tool with Microsoft's platform is this workflow remains unchanged as you move applications into the cloud. So if today you're running most of your applications on-prem, you can adopt this as it is today and start using Azure identities. And as you migrate to the cloud, you can continue to use the same integrations, the same workflows. The background details may change a little bit, but our tools provide you that consistent abstraction layer that will let you continue to use the same workflows, whether your application is running in on-prem or in cloud. With a combination of our tooling and Microsoft's platform, you have the ability to get started on your zero trust journey today. We've thrown a lot at you today. Let's take a quick look at a couple of things that you can get started with today and start safeguarding your data in today's hybrid cloud, multi-cloud world.
Yeah, so I'm on a couple things that I would suggest that people give consideration to is get rid of the idea of implicit trust. In other words, like you were describing, trusting an IP address as proof that a user is who they say they are, but move to explicit trust like identity. We still want to use the principle of defense in depth. And so that means you don't just do away with perimeter defense, but that shouldn't be the only method of protection that you leverage. The second one would be the principle of least privilege. In other words, only give people the access to resources that they actually require, only give them that access for the time period that they require as well. So not just in time access, but just enough access as well. So the principle of least privilege. And then the third one that I'll touch on is, as much as possible, verify every transaction. So treat all the traffic that is coming across your network as untrusted and verify users' identities in order to confirm and gate the access that they have to the data on your network or the resources on your network.
Yep, David, identities are key to all of this. Instead of IPs, we want to use identities to get access. Well, you also need to secure identities. The way to do that is making sure that once we've used the identity for access, we are revoking it as soon as we're done using it. Instead of creating users and letting them languish for months on end and later on going and reviewing at the end of the year or around the audit time and removing those, figure out an automated way to do these things so that your privileged identities are harder to misuse. The other way to kind of reduce the risk from identities being misused is by reducing the amount of time that a specific credential that identifies a specific identity, reduce the time that it stays valid for. You can do this by forcing re-authentication accompanied by credential rotation, which will reduce the time that a given credential stays valid for. So even if it's leaked, the risk from it is drastically reduced. To support the things that we've talked about, a smart thing to do would be start tracking your credential usage today. If you work on highlighting identities that have been used for a long period of time, credentials that have been used for a long period of time, and credentials that are being reused in a lot of different places, that can help you get a handle on the level of risk that your organization is facing and where you might prioritize your remediation actions today. So identities are a key part of securing your data in the zero trust world. Hopefully you found some of these useful. David, thank you for your help today. Microsoft we could not do this with all the cool tools and analytical capabilities that come out of Microsoft's platform. And they're a key part of the zero trust story for us. Thank you for your help today.
Thank you for having me.
All right. Any questions or concerns that people had? We talked a bunch about how identities are kind of the key to safeguarding your data today, not relying on IP addresses, kind of a minor point in that, but identity and the way you secure access to those identities is kind of key. I think the one kind of common thing that we hear about when we're working with Vault is a question around how do we kind of keep track of or keeps access to Vault secure? I think, and again, the answer ends up being identities for us. You can configure different authentication methods for Vault. So if humans need to go in and configure Vault, they log in using their Active Directory credentials. And if applications need to go in and fetch secrets out of Vault, they're using their managed identities or some sort of automation to have time-bound credentials. There's a question in the slides, in the Q&A. Do we get a copy of the PPT slides? I think, Mina, can you help us with that? Would we be able to send a copy of these slides out, or do we just share the recording?
Yeah, I'll check with the team on that, but we should be able to.
Okay. Awesome. Any other questions that people have around, Microsoft's identity platform or their approach to zero trust and how it plays with us? Those would be interesting to see. All right, Mina, I think one thing that we've discussed, David, is how does security look different a little bit in this modern kind of cloud infrastructure world compared to what legacy data centers used to look like? Can you chime in on that a little bit? What has your experience been kind of helping organizations secure their cloud footprint versus what it used to be when they were running traditional on-prem networks?
Yeah, sure. So when companies are managing an on-prem network, they have a greater level of responsibility, right? So they're responsible for ensuring that the data center itself is secure, that the servers are secure, that the networking equipment is secure, and then from there, everything that layers on top of those devices or pieces of infrastructure are secure, including virtual machines or whatever it might be. That model kind of changes, well, not kind of, definitely changes when you move to the cloud, right? So at that point, the cloud provider takes a larger role in the security of the infrastructure. So Microsoft builds the data centers, makes sure that the data centers are secure, make sure that the people are operating the data centers meet certain qualifications from a security standpoint. And then Microsoft has a responsibility to protect the infrastructure of the cloud. In other words, making sure that things like DDoS attacks that are being performed against Azure broadly are mitigated. But then there's an element that then shifts, the responsibility shifts over to the customer for some of the things. And so things like securing secrets, right, that we were talking about, like with Key Vault, that's the responsibility of the customer. Making sure that identities are secure, at least partially, is the responsibility of the customer, right? Microsoft is responsible for securing Azure AD itself, but customers are responsible for ensuring that user authentications are using secure protocols and making sure that passwords are strong or using MFA ideally. So it's kind of an evolution of the responsibility from purely being responsible for it yourself as an on-prem service provider to sharing that responsibility with a cloud provider. So it does take a little bit of a shift in thinking, but I feel like many customers are kind of understanding the benefits of that, leveraging the scale of the cloud providers, not just Microsoft, but like AWS and others that have very robust security capabilities. That's proved to be beneficial for them in many ways. So that's just one area.
Right. Yep. No one can. I don't think a lot of organizations could weather the type of DDoS traffic that Microsoft can handle, right? And that shifts the risk equation a little bit and allows you to leverage the Microsoft platform in some ways, but then also there's some parts of the security that now organizations may have not been involved in that now they have to worry about.
Right.
There's a question about this solution being available in GovCloud or MilCloud. Do you have thoughts on that? And then I can chime in.
Well, I don't know about HashiCorp's piece of it, but things like Key Vault and Azure AD obviously are available in the GovCloud, but I'm not sure how your solutions will kind of integrate or be part of that.
Yeah. So from our perspective, right, our solutions come in kind of two flavors. One is as a service. That portion or that consumption pattern is not available for GovCloud and MilCloud today. But the other option is to use our tooling, our licensed binaries, and you run them on your own. And since all the binaries require our infrastructure, you could, wherever you can spin up virtual machines or containers to run those programs, you can do that. So it's, very valid for situations like GovCloud, MilCloud. And I know specifically for GovCloud, where I've done, been involved in a couple of discussions, there's some kind of additional tuning required. So we're talking to the correct APIs that are available in GovCloud, but that's the benefit of a platform type of solution like Vault, where everything is API based. We can tune these things so that, even if in the background the APIs that we might use for regular Azure versus GovCloud might be slightly different, but that's configurable and tunable. And if you can run infrastructure, you can provide compute and memory, Vault can run there. And so can Boundary. Great question, Gerald. Are there any others? Otherwise, I think I'll thank you again, David, for the collaboration here and great insight into Microsoft's platform and how the platform itself helps you secure identity. And it plays really well into our tooling that helps you use that identity in a lot more different places and kind of build on the capability of the Microsoft platform.
Absolutely. And we're going to be seeing over the next several weeks, we're going to be seeing interesting things coming from the Microsoft identity teams, and just stay tuned. There's plenty more room to grow and strengthen security in the identity space. So very, very interesting to watch.
Yep, I'm sure there'll be some exciting announcements of the build. So we'll keep our ears to the ground here.
Yep.
All right. If there, I think I can hang out here for a couple more minutes if there are more questions. Otherwise, thank you everyone for your participation. Looking forward to kind of talking to you out there in the field as we work together to secure our data in this new cloud kind of world.